All right, we're at our last unit. So congratulations, those of you all who have made it. So let's get into the inner planets, talking about the universe here. So our objectives are going to be to list the inner planets in order from the sun, describe each inner planet, and compare and contrast other planets to Earth. So the inner planets are, in order from the sun, Mercury, Venus, Earth, and Mars. So a little mnemonic that we use is my very educated mother. Mercury, Venus, Earth, Mars. Okay, so the cool thing about the inner planets is that they're very dense. They're relatively small compared to the outer planets. They're very rocky, so they're called terrestrial planets. Terra is, it means Earth, which back then they just meant like land. So T-E-R-R-A is Terra, so they took T-E-R-R from that. So they're generally just saying that these terrestrial planets have Earth, so they have rocks. They have like a crust, kind of like the Earth. They're generally classified by having no rings and then few to no moons, and their atmospheric conditions range pretty drastically. So a cool thing about the inner and the outer planets is we have this convenient little asteroid belt that separates the inner planets from the outer planets, and that's going to be between Mars and Jupiter. So if you remember from 5 seconds ago, Mars is the last inner planet. So there it is right there. Jupiter is the first outer planet. So we've got an asteroid belt kind of right in between each of those. And then the inner planets are very close to the sun comparatively to the outer planets. And so then that's going to make them also comparatively very hot compared to the outer planets. So this is just like iron concentrations in the inner planets. Don't worry about that too much. What I'm just showing you here is the structure, and this is not to scale. Earth is generally a lot bigger than Mercury. So it goes Mercury, Venus, Earth, Mars. My very educated mother. Okay, so let's get to Mercury. Mercury is the first planet from the sun. Its diameter is about 4,879 kilometers. Its revolution is 0.24 Earth years. And so a revolution, this is important, is how long it takes for an object to go around the sun, in this case. So here's the sun. Mercury goes around the sun in 0.24 Earth years. So we calculate that in Earth years because our Earth year is 1 year around the sun, 365.25 days. So we just use that as a basis for all of the other planets. So this has a very, very short revolution. It goes around the sun very quickly because it's closer to the sun. The rotation, however, is 59 Earth days. So the rotation is how long it takes for that planet to completely spin around its axis. So the Earth has a day, it's 24 hours. That's how long it takes for that sucker to rotate completely 360 degrees. So Mercury takes 59 Earth days to completely rotate. So it's got a very slow rotation around its axis. And the axis is just basically an invisible line going straight through that planet where it kind of rotates around. That was weird. Sorry. But it's just an invisible line. And then imagine a planet like is like on the middle of this line. So it's just spinning 365 degrees. So, or 360 degrees, excuse me. So Mercury has no moons. Its atmosphere is almost non-existent. And we know this because we sent probes to pretty much all of the planets. And probes go out into space and they get data readings like gas, soil readings, temperature, that type of stuff. So we sent a probe to Mercury and it showed many large craters and almost non-existent gas. So that's how we know that Mercury's atmosphere is pretty much non-existent. Since it has a lot of craters, that means that there's nothing really there to stop the craters, the meteoroids, from impacting the land. So Earth has a really awesome atmosphere that stops meteoroids from turning into meteors and smashing into us. It only happens once every like 65 million years, and even longer than that sometimes. So Mercury has extreme temps because of this lack of atmosphere and the proximity to the sun. So during the day, it's about 400 degrees Celsius on the surface, and during the night, it's about negative 200 degrees Celsius. So night is just when the that object or planet is away from the sun. So it's the side that's not getting the sunlight, and that's technically night. So here's Mercury. You see all these craters on there. And then there's an example of a probe right there. So we send these suckers out into space, and then they take a bunch of readings. So the second planet from the sun is Venus. Its diameter is 12,104 kilometers. We call it our twin planet because it's pretty much the same size as Earth. It's got a very thick carbon dioxide atmosphere. So it's not exactly like Earth, but it does have a pretty thick atmosphere. It's around the same size as us, and its revolution, or its rotation, is 243 Earth days. So it takes 243 days for that thing to turn around completely one time around its axis. So day and night there is a long process. And then its revolution is 0.62 Earth years, which is relatively close. So it takes about 2/3 of the time that the Earth takes to revolve around the sun. That's the revolution. Venus has no moons, and its atmosphere is very, very thick with CO2. So that's going to create that greenhouse effect that we all know and love. So that makes it a very, very hot planet. It traps in all that solar radiation. So the planet's around 400 degrees Celsius all of the time. It's a very stable environment, but it's extremely hot. So here's just a comparison of Venus to Earth. It's, relatively similar size. This actually looks like the same picture of Mercury, but whatever. Earth is the third rock from the sun. Its diameter is 12,756 kilometers. Its rotation is 24 hours, which is one day. We know that. Its revolution is 365.25 days. So 0.25 is 1/4. So that's where we get our leap year. Every 4 years, we add another extra day. Interesting thing is this is not a new scientific occurrence. The Mayans had a very, very precise calendar based off of cogs that turned. So every day they would turn a cog, and they had one cog at the end that had four like little things that turned, and teeth is what they're called. So it had 4 teeth on it, and every 4 years that cog would turn. So they accounted for the leap year, 2,000 years ago. Then we just kind of forgot about it. So our atmosphere is very unique, and it's the reason why we have stable climates. Our atmosphere is a lot of oxygen, nitrogen, CO2, methane, or water vapor. We have all sorts of stuff in our atmosphere, and that's what's keeping it stable. So imagine if we just had CO2, we would be back to that Venus effect where we'd have 400 degree weather, Celsius degree weather all the time, which is even hotter than Fahrenheit. So we have a lot of liquid water, and we're pretty much the only planet around that has liquid water. Not very many planets, even in the universe, have liquid water, so we're extremely lucky. And then here's just a funny little graphic of flat Earth. This is not true. Sorry for those believers. But here's a picture of the Earth, and you can see it's very round, and we've got a little bit of shade here, and that's from the moon. It's hard to get a picture of the full Earth because it's hard to make it so that the sunlight, get it at the correct time that sunlight is hitting all of Earth, and it's not too bright to be able to take a picture. So Mars, it's the fourth planet from the sun. Its diameter is 6,794 kilometers. Its rotation is about 1 Earth day. It's 1.09 Earth, or 3 Earth days. It's very close. Its revolution is about 2 Earth years, so it takes about twice as long to go around the sun as us. Its atmosphere is mainly CO2, so we're going to see, that it's going to be hotter than Earth a lot of the times. It has 2 moons. They're very oddly shaped due to meteor impacts. So moons don't have atmospheres, so they get hit by asteroids, and they've been around for about, like 5 billion years about, so it's a lot of time to get hit by planetary objects. Mars has seasons just like the Earth, and that's due to its tilt around 25 degrees. So it's kind of like Earth. Earth is 23.5 degree tilt on its axis, so Mars is, probably like that. So it has seasons, and the tilt is the reason for seasons. We should know that already. And on Mars, we have found that ice caps grow on it. They shrink with the tilt towards the sun, and then they expand with the tilt away from the sun during seasons. So that perhaps indicates that there is a possibility for liquid water on Mars. So we talked about probes. Here are just some really interesting probes that went on Mars. We had the Pathfinder, which found oxidized soil, rocks. It checked the atmospheric gases of Mars. The oxidized soil seemed leached, and leaching only occurs when there's liquid H2O running through it, and that's water. So that was just a little bit of evidence that Mars has or had liquid water on it at some point in time. Then we had the Global Surveyor, and it found what appeared to be dried up stream beds, just indicating more evidence of liquid water at some point in time. Then we had the Odyssey, and that found evidence of ice caps on both poles. We since now know that this is fact. They do have ice caps on both poles of Mars. And then we had Viking, which found no signs of life whatsoever, so don't get your hopes up. And then here's just Mars. You know, we've got the solar polar cap, the north polar cap, clouds. These clouds have water vapor in them, and then there's just a bunch of land all over. And that is it for this section. So if you have any questions, comments, or concerns, like always, let me know. Otherwise, have a wonderful week.